Hello students, this is the recording for the Unit 2 project for the first half of the project, all about your element. So make sure that on the first slide that you type your name here, that way we know who this project belongs to. For slide number 2, you need to go ahead and choose just one of the elements that are boxed in red, here, here, or here. Please do not choose any elements outside of the ones boxed in red because that will make your project a lot more difficult and you won't receive credit for it. So do not choose a non-boxed element because it would be significantly harder and you won't receive credit. Okay. Now let's go ahead and take a look at our next slide here. So once you have chosen your element, all right, now you're going to go ahead and do some analysis on it. So we need to know which element did you choose and why. So you'll go ahead and type out, I chose this element and why, right? So it chose which one from here. And then go ahead and Google your elements square on the periodic table. You can also just go to ptable.com and use the one on ptable.com. But what I would recommend is just Google, for example, if you choose one, which I'm going to choose one that's not in red, but if I were to be able to choose silver, even though I'm not, I could look up silver, periodic table, and then just look underneath images. All right, and then any of these that has, it says you have to have the atomic number, which is that number at the top, the symbol, the name, and then the atomic mass, which is the non-whole number, the one with decimals at the bottom. So taking a look here, any of these here would work, right? So just right click and copy it, come back over here, right click and paste it, and then make sure you put it in the right spot. Again, do not copy this one. Do not copy this. Silver is not an option you are allowed to choose. Okay. All right, so then we're going to go ahead and take a look here at, now we're going to go ahead and take a look here at talking about the Bohr model. So for the Bohr model question, you're going to go ahead and get a Bohr model of your element. So same thing, come over here, and instead of looking up silver periodic table, look up silver Bohr model. Sorry, don't look up silver, obviously look up yours. And you can see plenty of examples of Bohr models, right? So just choose one of these, and same thing, you would copy it and paste it here. All right, and just move it to where it belongs. Then it says, where are valence electrons found? So I'll go ahead and tell you right now that the answer to this one right here is on the outermost shell. So you can copy that answer. Feel free to copy this answer. Okay. And how many valence electrons does your element have that you chose? Well, that's based on the outermost shell of your Bohr model. So let me go ahead, actually I'll include that picture again just for a moment. All right, so if I were to ignore everything in the center here and only look at the outermost shell, right, I would see that this one has one valence electron, right? So in this case, I would write 1. But obviously yours will be different because you are not allowed to use silver. You are not allowed to use silver. Please count the outermost electrons for your Bohr model. All right, so let's go ahead and then take a look here at the next slide. Right, so this one says you need a real photo of your element. Again, you can either go to ptable.com or Google, right? So if you want to Google silver, you can see plenty of pictures of silver, or if we go to ptable.com, which I highly recommend, you can get to it just by clicking here and then clicking ptable.com. I can see silver right here, and you can see the entire Wikipedia page. So if you click here and then over here underneath right up where it says silver, you'll see a picture right here. So you can right click and copy this image and come over here, again obviously for your own element, not for silver. Okay, all right, so that will give you your real photo. All right, now question number 6 is asking about your element's atomic number and its mass. So atomic number, remember, is going to be the number at the top, so the whole number at the top of your square, which you should have put your square right up in this slide, slide number 3. Okay, if you, I'll take a look right here, for example, though, of silver. All right, so silver's whole number at the top is 47. So for me, my example, right, example for silver would be 47. And remember that the atomic number is also the number of protons. So these two things right here are the same. Okay, so this means that silver must always have 47 protons as well. So my example would be 47 protons. And remember that we talked about this a whole bunch. Atomic number is the same as the number of protons and cannot change because then identity would change. Okay, so if it didn't have 47 protons, it wouldn't be silver, right? So it has to have 47 protons. It has to have that atomic number, otherwise it's not silver. Okay, all right, so let's go ahead and then take a look here. Sorry, let me move that. The weighted average atomic mass, that's the number at the bottom. So this is the number with decimal places at the bottom of your square, right? And same thing, you should have been able to find this from your slide number 3 picture. So for example, taking a look at silver again, silver, you can see the number at the bottom is 107.87. So my example here is that silver would be 107.87 AMUs, and the units are already there for you, so just make sure you keep your units there. Everything should have units. Okay, AMU stands for atomic mass unit. That's the unit for mass of an atom. The atomic mass of the most common isotope, remember that we talked about in class that the most common isotope is generally the one that is closest to this number. So the most common isotope mass does need to be a whole number, and all you're going to do is you're just going to round this answer right here. So remember that when we round, right, if the number after the decimal is small, that means 0 to 4, you should keep the number before the decimal the same. But if the number after the decimal is big, right, 5 to 9, then round the number before the decimal up. All right, so let's go ahead and take a look at our example here. So if you take a look here, I can see, let me grab a different color here. All right, I can see here that this number after the decimal is a big number, right? So 8 is a big number. And so since 8 is a big number, this number before the decimal, my 7, instead of keeping it the same, I'm going to actually round it up. So my final AMU of my most common isotope should be 108 AMUs. So again, your most common isotope is usually the one closest to the weighted average atomic mass. Most common is usually the whole number closest to the weighted atomic mass. And remember, this this atomic mass is coming from protons plus neutrons. That's why it should be a whole number if you're talking about the most common isotope. Okay, all right, so that's my examples there. Let me go ahead and just kind of clean this up a little bit, right? So we said for our example that there was a atomic number of 47 and therefore 47 protons. We said that the average atomic mass was 107.87, and therefore rounding that, my most common isotope is 108 AMUs. All right, so taking a look here, again, the definition of atomic mass is protons plus neutrons. Again, we always ignore electrons because they are too tiny. They have what's called negligible or barely any mass, negligible mass. Okay, so that's why when we talk about the equation for atomic mass, it's only protons plus neutrons. So what it's asking here is to calculate the number of neutrons in the most common isotope, and you should be able to do this because, again, we already have the atomic mass of our most common isotope right here that we decided, and we already have the number of protons from our atomic number. So if I were to plug those in, 108 right here, and then 47 right here, I should be able to solve for neutrons. Now, the way that you solve this, again, this is an example, do not copy this example, because this is for silver. You do need to be using your own element, right? But if I were to do this, right, so 47 plus our neutrons here, I want to try to get neutrons by itself. And in order to get neutrons by itself, you need to get rid of whatever next to it. So currently what's next to it is addition, adding 47. And so I need to do the opposite, which would be to subtract that 47. So I would subtract this 47, and that gets rid of it on the right-hand side. But whatever I do to one side, I have to do the identical same exact thing on the other side. So I'm going to do the same exact thing on the other side and subtract 47 over here. And then if I were to go ahead and calculate that, so let me grab my calculator from Google. So if I do 108 minus 47, I would end up with 61, right? So I would end up with 61 neutrons in the most common isotope of my element. So I know the number of protons now, and I know the number of neutrons based on using the equation for atomic mass of our most common isotope. All right, so that's that slide right there. Let's go ahead and take a look then at slide number 7. So what group is the element you chose in? So we're going to go ahead and take a look at the group numbers and their common names. So first off, for the group number, you're going to want to go to ptable.com. All right, so group number, go to www.ptable.com. Again, you should have this open for the entire project anyways. So going to ptable.com, you're going to take a look at your element, right? And so you can see, remember, the only elements you were allowed to choose were here. Actually, I have the picture right here. Let's go ahead and just do it from here because this is the same picture. All right, so for example, if you choose any of them in this first group, then you are, again, the group numbers are at the top. So these are the group numbers. All right, so you can see here that we have group number 1, 2. You could be in group 13, 15, 16, or 17. All right, so those are the only groups that we're allowed to have. You won't have any groups in 3 through 12 or group 14 or group 18. So again, just look at where yours falls and then look at the top, and that'll tell you what group number that is in. All right, so let me go ahead and clear that out and take a look here. So again, your group number is going to be the number at the very top of the column in the periodic table. And again, we can just find that again from right here, from this slide number 2. Okay, so then what you're going to go ahead and do is you need to know what is the common name of that group. So we haven't really taken a look at this yet in class, but we will, and we have actually seen them before in one of our warm-up questions. So taking a look here, we can see that depending on which group you're in, I said you could be in group 1, 2, 13, right? 1, 2, 13. You can't be in group 14. You could be in groups 15, 16, 17, and you can't be in group 18. But these are all the common names, right? So if you're in group 1, you would say alkali metals. If you're in group 2, alkaline earth metals. Group 13, boron family. Group 15, the pnictogens. Group 16, the chalcogens. Or group 17, the halogens. Now the nice thing is, you might have noticed when we were first looking at that it actually has some of the names up here. So again, here are the pnictogens, chalcogens, halogens. The names are actually already there. Again, this one right here is just called the boron family, which is easy because boron is actually the first element there. And then again, this first group right here is the alkali metals. And this second group right here is the alkaline earth metals. Alkaline earth metals. All right, so even though we haven't really talked about the characteristics of each of these groups in detail yet, again, we have seen it in class. You should be familiar with them, and the answers are right here. So that should be easy peasy to do. All right, so now let's go ahead and take a look at the number of valence electrons that your element has. Again, the number of valence electrons you actually already determined on slide number 4, right? So again, this was already determined from slide number 4, and right, this is the outermost electrons. However, even if you don't remember exactly what you put on slide number 4, remember that the ending number in the group number is actually the same as the number of valence electrons, right? So the ending digit of the group number is identical to the number of valence electrons. So this is, again, another thing that we talked about in class. So if I take a look here at our table here, right? So if you take a look here at our table, again, you can see that if you're in group 1, right? If you're in group 1, you have 1 valence electron. Group 2, you have 2. Group 13, just look at the last digit, which is 3, and therefore you have 3. Again, you can't be in group 14, you can't be in group 18. Group 15, the last digit is a 5, so it has 5. Group 16, the last digit is a 6, so it has 6 valence electrons. And group 17, the last digit is a 7, so it has 7 valence electrons. So I would double check it both ways. Make sure that your number is consistent with your valence electrons are consistent with your group number, as well as with what you did on slide 4. So valence electrons should be based on group number, as well as what you did for the Bohr model on slide 4. Okay? So to become stable, how many valence electrons does this element want to lose or gain? So remember that in general, elements want to elements that only have a few valence electrons, right? So if you only have a few valence electrons, 1 to 3, then you will lose electrons, okay? On the other hand, if you have most of your electrons, let me move this over here. Okay, if you have most of your valence electrons, remember most atoms want around 8, so most would be 5 to 7, then you will gain electrons to reach a total of 8, right, that octet. So again, the purpose of losing them is this way you can drop down to a full shell, right? To drop down to a full shell. And the purpose of gaining them is to fill up your current shell. So just as a tip here, right, we just went over this, that if you are in groups 1, 2, or 13, these groups only have a few valence electrons, and so these groups are going to prefer to lose their valence electrons, 1, 2, or 3. And if you're over here, the pnictogens, chalcogens, or halogens, 5 to 7 valence electrons, you will prefer to gain, right? So prefer to gain, and specifically prefer to gain however many it takes to get to 8. So if you have 5, you're going to want 3 more, right? So these ones you just lose however many you have, -1, -2, -3. Chalcogens will need 2 more to get to 8, and the halogens will need 1 more to get to 8. Okay, so that should help you out with this question then. So taking a look here, will it gain or lose? Again, gaining if you already have 5 to 7, losing if you have 1 to 3, and then how many will it gain or lose? We just went over that, right? So if you're in group 1, you subtract 1, group 2, you lose 2, group 13, you lose 3, group 15, remember you have, let me just take a picture of this just to make sure it's super clear. So again, yeah, so taking a look here, again, right here. So if you're in group 1, you lose 1, group 2, you lose 2, group 13, you have 3, so you lose 3. Group 15, you have 5, and so you just need 3 more. Group 16, you have 6, so you just need 2 more. And group 17, you have 7, you just need 1 more in order to get to a total of 8. Then based on its location on the periodic table and its valence electrons, is it a metal, nonmetal, or metalloid? So just so you know pretty easily that if you're in groups 1 or 2, you are definitely a metal. If you are in groups 16 or 17, you're usually a nonmetal. But these ones in between, the 13 and 15, you could be a metalloid. So it's really good to actually look at the ptable.com because that will help you figure this out the easiest. So ptable.com, taking a look here, right? So you can actually see here if you highlight metals, you can see if yours is a metal, right? So if your element is highlighted when you hover over metals, then you know it's metal. If yours is highlighted when you hover over nonmetals, then you know it's a nonmetal. And if yours is highlighted when you hover over metalloids, you know it's a metalloid. Okay, so again, all of this can be found from www.ptable.com, hover over metal, non-metal, metalloid to see when your element is highlighted. But again, in general, metals will lose electrons, non-metals will gain electrons, and metalloids are in between. All right, so that's what we need to know for the first half of the project. Let me know if you have any questions. You can also come to office hours.